I hope you able to see my screen clearly. Any confirmation that you are able to see my screen?
Yeah, we can see it. Clear. From my side, it's clear.
Okay, so I'll say my the trainer Martin Idecha, and this is our third session on IPRAN training. So I've mentioned that we have had two sessions. We discussed about the general architecture of the IPRAN network, and then we also went ahead and discussed how to do the IP design for IPRAN network and also IGP design for the IPRAN network. So this is our third session. I'm hoping that we'll be having many more sessions in the coming weeks so that we try to close on this training maybe in the next 1 or 2 months. So we'll be having a session after every 2 weeks in the new plan so that we don't stretch it past many months. So starting from this week and then after 2 weeks we'll be having another session probably to discuss about BGP design for IPRAN, and then we'll go ahead and do another session on how to do the configurations and go ahead to cover all the remaining topics on the IPRAN network as we progress. So our sponsor, this is Life Technologies. And we have a website where we publish documents, lab simulations, and we also have a YouTube channel. This is Life Technologies. If you search it on YouTube channel, you will find Life Technologies YouTube channel. And please, encouraging you to subscribe and to share the content that is shared on our channel. We have lab simulations on Nokia, we have lab simulations on Huawei, we have lab simulations on Juniper, and there will be many other content that will be published in the upcoming videos. So for today's session, we are doing a lab simulations, and our focus is mainly how you do the configurations of ISIS. But of course, we need to also bring in the theory part. I know there are those one who missed the theory sessions, and when we are doing the configurations, we'll be mentioning some sections about the theory. We know that ISIS, this is an IGP protocol, IGP, and it's commonly deployed. Nowadays, many of the IPRAN networks, they are using ISIS as the IGP protocol. Of course, we discussed why and how to design it in our last episode. So this was just a recap, maybe for those one who have missed our last two sessions, or maybe you joined, but again, we still need to understand the topologies on the IPRAN architecture. So this was the general topology of the IPRAN architecture, starting from the access, which is the access network, to the aggregation network, and then we have controllers, the BSC, RNC. We also need the NMS for management. We have the BTS, the base station controllers for different, the base transceiver station for different technologies. We can have 2G, 3G, 4G, and nowadays we also have 5G. So from the BTS, we are connecting to the CSG, the cell site gateway. The cell site gateway is connecting to the aggregation site gateway, and then we also have the RSG that is connecting to the controller, the BSC and the RNC in the core side. To our next slide, we also talked about IP address design for IPRAN network. So you require different IPs for your deployment, for example, the system IPs, because you need to manage these nodes. So definitely you will require management IPs for every node in the network. That's what we are calling the system IPs. Then we have the point-to-point IPs, the one that you will be configuring on the point-to-point connection between different nodes. From the CSG to the ASG, you need a point-to-point IP. And even from the CSG to the BTS, you also need a point-to-point IP. So some of the best practices we mentioned, you need to assign a specific blocks to specific regions on clusters. So if you have your network divided into regions, definitely it's recommended that you assign different blocks of IP addresses or different subnets. It could be /24, it could be /16, depending on the requirement and the size of the network. So we use /31 for point-to-point connections, and then we use /32 for the system IPs or the management IPs. And another thing that I have to mention is you need to have a proper IP management database to manage the used and free IPs. This one will ensure that you don't have duplicate IPs in the network. Also, you need to continuously audit IP address usage of your network. To the ISIS design for IPRAN, these were the key concepts that we discussed last session. ISIS areas and levels. So the network will be divided into different areas, different levels. We know we have 3 levels, level 1, level 2, level 1, 2. So you need to choose which level are you using. Many times we use level 2 for many deployments. ISIS cost, definitely. We know that ISIS selects the best path based on cost. So how do you configure cost on your network? Those are some of the things that we'll be demonstrating today. The network types, we have point-to-point, we have broadcast. Which one are you going to use? Many times we prefer the point-to-point connection. We have the access and aggregation import. So once you split your network into different access and aggregation rings, definitely you need to achieve communication between different or among different nodes. So that's where we are now bringing in the idea of aggregation and access route import between the two processes, 2 or 3. The network entity, you need to know how to generate, and then ISIS name, ISIS authentication, IGP, LDP sync, PFD for IGP. So these are the key concepts that we discussed in our last 2 sessions. Just a recap of the same. And we can now move to today's topic, unless there is any question or any comment from the members. Any question from the members before we move to the next? Okay, so I mentioned that today our focus is on the lab configuration, and this is the topology that we are using. So from this topology, you can see that we have different access rings. We have access ring 1, and we also have access ring 2. And then we have the aggregation ring. So the aggregation ring will be comprising of the ASGs and the RSGs. Sorry. And then in a network, definitely we have the rings. In terms of the topologies, we have the rings. You can see that here we have a chain. So this chain, we are also configuring a different ISIS process for this chain, separate from the one that we are deploying for these 2 rings. So you can see that from this topology, we have access ring 2, we are giving it ISIS 30, and then access ring 1, we are giving it ISIS 20, aggregation ring 1, we are using ISIS 100. And you can be having multiple nodes. You can see that these are sparse from access ring 1, and we also have sparse from access ring 1. So this one, they will be in the same ISIS process. This one will be configured in ISIS 20. This one that are spanning from ISIS to 30 will also be configured in ISIS 30. And of course, you could be having other sparse from these nodes. You just need to do proper planning before you start configuring your IGP, so that you have a clear design and a very manageable network. The one that you don't have to have the network loops caused by the poor implementation of the IGP. So it's always recommended that you follow the standard design. You split your network into ring, assign different IGP processes for every ring, and then of course I mentioned that we also need to go ahead and perform route import between the different nodes. So this is the topology. I hope it's clear. So moving to the configuration roadmap. Of course, the first thing that you need to do when you are setting up a network is the general, like the hardware installation, the powering, power checks, the cooling checks, cabling, labeling the connections. Once you've done that and now you are ready to start the integration to the live network, of course, the data preparation is done before even you do the installation. Even before you start doing the installation, you already have the data prepared. You know which IP address will be assigned to which node. You know which system name you will be using for this node, depending on your company standards. So that will be the first step of data preparation, and then the next step is to configure sysname and IP address on physical and loopback interfaces on all routers. So system names, of course, this one you always have to configure based on your company naming conventions. And even the description on the interfaces, you need to give the descriptions and the system based on the company convention. If they say you need to start with the site ID, so you start with the site ID, you give the site name, maybe it's CSG1 or CSG2 or RSG1, you specify that this is SG1, and then you go ahead and configure that system based on the company standard. Once you've done the basic configuration of sysname and IP address, we'll go ahead and create respective ISIS process and activate on the interface. So you've seen that we have already designed our ISIS rings and the ISIS processor that we'll be using. So the next step, the third step, will be to create the respective ISIS processes and activate on the interfaces. Once you've done the
Sorry, Brother Martin.
yes.
Just before we move on, the process, ISIS process, is it a must to put them into separate numbers, or we can have just one process, ISIS process, one for all the network, the same number?
Like you have ISIS 100, all.
What for all the whole network? Only ISIS 100. Is that fine also?
Anyone who can respond to that? Can you have one ISIS process for your entire network? That is the question.
Yes, hello.
Yes. Proceed.
Okay, you can have one ISIS process for the whole network, but it will cause issues in troubleshooting. When you divide your network in rings, and then each ring you have a different ISIS process, in case of any issue, you'll be able to troubleshoot easily. So troubleshooting is one of the answers. There could be other answers.
Okay, anyone
Thank you.
else with a different response? I will say first it depends with the size of your network. If you have 3 routers, 4 routers, 5 routers, 10 routers, yeah, you can go ahead and configure in the same ISIS process. But if your network is huge, like a service provider network with thousands or even 10,000s of routers, definitely we recommend that you should segment your network into different ISIS processes. And of course, Terence has mentioned
Thank
about
you.
the troubleshooting. When you have smaller rings in different ISIS processes and you have done proper implementation, it's very easy to troubleshoot the network. You know when the issue happens, you know where to look at. So it will be easy to
Thank you.
troubleshoot and manage that kind of the network. So once we've done our ISIS configuration, of course, we need to verify the adjacency status, check the routing tables, and many other details about ISIS. Then the fifth step will be to do now the access aggregation route import between the access and aggregation. So we are importing the access process to the aggregation. We are also importing the aggregation to the access, but we don't import everything. There are just specific prefixes that we need to import to ensure that we have reachability. The sixth step will be to closing access rings on aggregation nodes. So when you have a ring terminating on two aggregation nodes, you need to extend that IGP process so that you have a ring closure between the aggregation nodes. So that will be the 6th step. So the 7th step is on ISIS cost planning and configuration. So we mentioned that there are three different methods that you can use to configure the cost in our network. So we'll be demonstrating that. And then we also need to implement authentication for ISIS to ensure that we improve the network security, which we cannot ignore. And then we'll also be looking at how to improve network convergence speed. So that is the configuration roadmap. So we are starting part 1. From part 1, this is the topology setup in ENSP. And nothing is configured because we'll be configuring everything step by step. Of course, the scripts are ready, but we'll be configuring and doing the troubleshooting together as we move on to the next and the subsequent steps of the lab. So the first thing I've mentioned is to do the data preparation. And data preparation can be in different stages. I've mentioned that we need to have the system name, the loopback IPs, and even the point-to-point IP that we'll be using to do the point-to-point configuration, the back-to-back connection between the different nodes. So you need to have the systems. Of course, here I'm just using generic names, but when you are doing this, always follow your company's naming convention. If they specify that you need the site ID, site name, the site number, or any other details, always follow the company's convention when you are doing the deployment. So you have the system names, you have the loopback IPs. Loopback IPs I mentioned we are using /32s. So we are using 1.1.1.0/24 as our system management. But again, we subnet it and just give /32 IPs for each node. So this one will be the details for the SG and RSG. We have the details for the CSGs. So we have 14 CSGs, we have 2 RSGs, and we have 4 ASGs. And then for the point-to-point connections, these are the IP that have been assigned. You can see from the topology that all the IPs have been indicated very clearly so that it's easy to do a similar implementation even in your own lab. So once you've done the data preparation, the next step is to now start your configurations. But before you start the configuration, I mentioned that this one will be more a mixture of theory and lab. So you need to perform checks on the physical installation, check the grounding, check the device powering, and do power tests. If you have redundant connections, you need to check the cooling and temperature of the device, ensure it's operating in the optimal environment, check the physical connection, and ensure the ports are up. Of course, the physical checks from the port level, you need to ensure that your patching is okay. You need to do check the cabling and perform proper cable labeling. And the best practice for basic configurations, you need to follow the naming convention when assigning names to sites. You need to provide proper interface description for all interfaces. I've mentioned when you are giving description, this one will also depend on your company standard. But you can see that, yes, you can give the local site name, the port, and then you give the remote site name and port as part of the description. This one will come in use, especially when you are doing the troubleshooting of the network. Maybe you just need to know like this interface is connecting to which node and which port. It will be easy to do that. Use /32 IP address for management. Use /31 IP address for point-to-point. And then always remember to commit and save the configurations. Don't just do the configurations and then you leave the site. Maybe there is a power issue and all the configurations are cleared. How do you reach the device? So when you are doing the integration of the new device, always remember to commit and save the configurations after you've done the integration activity. Another thing, you need to test the point-to-point reachability. So when you are doing the basic configuration, of course, you don't wait to start configuring your protocol, then you come back to test the reachability. No, you should go step by step. Once you configure the point-to-point, just test the point-to-point IP and ensure it's reachable. You use the ping command. Once you have the reachability, you can now go ahead and do other configurations like SIS, BGP, etc. So step one, I've mentioned that we are just doing the configurations. So let's first see the configurations. These are the configuration that we are running for the basic configuration. We are just configuring the system and the interface IPs. So Huawei has different views. We have the user view. So before you start doing any configuration, you always have to go to the configuration view. So we use the system command to go to the system view or the configuration view. Once you are in the configuration view, you set the system name. I've used the generic system name. Of course, I've mentioned that when you are doing this deployment, always use the standard requirement from your company. But this is how you configure the system. System RSG01. And then, please mute.
Okay.
So once you've configured the system, now we go to the interface configuration view. So under the interface configuration view, that's where we'll be doing the configuration for the interface parameters. You can see, for example, we are creating Loopback 0. We are assigning the IP address. So use the command IP address. This is the IP address we are assigning, and then you need to give the mask /32. Other physical connection, this is, of course, Loopback 0. It's a logical interface. And then we have the physical interface. On the physical interface, you also have to go to the physical interface view, and then you give the description. I mentioned that, for example, this one, you can see that we are labeling it to SG04, GE002. Once you've done that, you also assign IP address on the interface, and you do the same for all the other interfaces on the router, the ones that are up, and you need to do connection to those routers. So these are the similar configuration that we'll be doing for RSG2, SG2, SG3, SG4. We do similar configurations on the router, the system name, interface, the loopback, the management IP. This will be the loopback IP is always used as the management. Of course, you can configure based on the requirements, and then we have the point-to-point connection. So these are the configurations. Unless there is any question from the team, we'll go ahead and do the configurations.
Hello, Mr. Martins. Can you hear me?
Yes, yes.
Please, I may need the configuration. If you can share it in the link, so at least one can download it for practice.
Yes, yes. The PPT will be shared. Once we finish the session, the PPT will be shared with the configurations.
Oh, okay. Thank you very much.
You're welcome. Does anyone have a question on the configurations?
Yes, Martin.
Yes.
Can you hear me?
Yes, yes.
The description for example, in that first example, to ASG04 gigabit 002, that's gigabit 002 of the ASG04.
Yes, yes.
And one more inquiry. I know it might sound stupid, but I thought on a point-to-point network we used a /30 subnet mask. By default, doesn't a /31 make, or doesn't it give us only one usable IP address?
A /31 gives us two usable IPs. For example, if you check on this one, like if you see the connection between RSG2 and RSG1, this one on 002, you can see that we are giving .4 on this end. On the other end, we are giving .5. So you have the two usable IPs, 4 and 5. So
All right, thank you.
many times we use like that one for the point-to-point connection, but there are cases where we use /30. It's also okay.
Okay, thank you.
Okay. Any other last question before we do the configurations?
Yes, Brother Martin.
Yes, yes.
Yeah, sorry. I see it's something that I have noticed, like maybe I have to find
Hello.
the look back is considered to be for. Can you hear me?
Yes, yes, I can hear you.
Yeah,
You
the
are
look
you are breaking.
back, is it considered for control planes about the configuration of IGP between routers or for management, or we cannot use a physical interface, or just because of the physical interface can go down, or maybe there is the correct reason why we're using loopback for point to point or something like that.
Anyone who can respond to the question?
Hello.
Yes, yes.
Yes.
Sorry, maybe you can repeat the question. My network was a bit bumpy. I can get question clear.
Okay, my question is, I have noticed that most of the configuration it is point to point. There is loop back. We are using loop back interface. So I was like, is there the good reason that not like good reason, but the main fact of using loop back instead of a physical interface for connectivity between routers?
Yes, who is responding to the question?
Just to, I think the main one of the reasons is that loopback IP addresses are more stable. The interfaces are more stable compared to physical interfaces.
Okay, thank you.
Maybe just to add why we use the loop back. So we usually use loopback mainly when establishing things like BGP sessions, maybe LTP sessions. So you could be finding that there could be many routes to maybe to that router. So if you use a loopback and you know a loopback interface will never go down. So it means the BGP sessions will not go down if maybe a single link goes down because there are alternative routes.
Thank you.
Yeah, thank you. So I hope the question has been answered. The loopback will never go down. It's always up. Wherever you have multiple routes, you can always reach it via the alternative routes. So that is why we are going ahead to use the loopback IP as the management IP, as the management interface. Okay, so
Thank you.
we'll go ahead and start the configuration. So we'll start by the first router. So we have RSG1. From RSG1, when you log in, of course, you are in the user view, so you need to go to the configuration view. So that's why we need to configure the system command first. And on this simulator, of course, we don't have the commit command, but when you are configuring on the real router, the real hardware, always remember to do the commit command for it to take effect. We'll try to be fast so that we go to the verification stage. So we have RSG2, and then we have our SG's configuration. So we are just configuring the sysname, the interface IPs, and then the loopback IP, the physical and the logical IP details. So on SG1, we'll do the same. So we'll have to test the connectivities once we have done the basic configurations. On SG2, we'll do the same. So just allow me to do the configurations and then we can go ahead and do the verifications. Any question as I continue to do the configurations? And this one we are just configuring the IPv4 address. If you have IPv6 addresses also, you can go ahead and configure. These are the CSG configurations. So for the CSGs, we are also doing the same. I hope you can see the configs. We are also just setting the sysname, the interface IPs, the loopback IP, the descriptions, and the back-to-back connection IP addresses between the different nodes. I'll go ahead and do the configuration for the CSGs, starting from CSG1. Any question from the team? Or any comment? For CSG3, we do the same. We have the sysname set to CSG3 and then the interface parameters. Then CSG4. And when you are doing the configuration, it's always good to also check the prompts, the screen output that is coming from the command. Maybe you have assigned IP address or it didn't pick, or so you always have to check these prompts that are coming on your screen. It may tell you like you are configuring a wrong IP mask or something like that, or you don't have that interface existing on that node. So it's always good to pay that attention when you are doing the configurations.
Hello, sir.
Yes.
Yes, I have one remark. I think it's also recommended to enable LLDP protocol on all router,
Exactly.
the LLDP protocol to discover link.
Maybe you can just go ahead and explain what LLDP does to those one who may not be familiar, so that they understand why you need to enable LLDP.
Yes, LLDP is a protocol that allow devices to discover link from to on if in all device you can easily see the all the peering from L2.
Okay, that's true. So when you enable LDP, at least, especially for the remote deployments, you only have the technician going to site to do the connection to the new equipment, and then you need to verify that you can be able to see the remote the connected devices. So the LLDP link layer discovery protocol will help you to do that. So when you are doing the configuration on the live network, especially on the real boxes, on the ENSP you cannot see that, but on a real router, ATN or the NE8000 or any other vendor, it could be as IXR, it could be as R2S. When you enable LLDP, you are able to see the remotely connected devices, which is also very handy when you are troubleshooting the connections. Thank you. Anyone else with a question or a comment? So I'm configuring CSG8, same parameters, configure the sysname and the interface parameters. I had to prepare the script because if we were to run command by command, it will take us a whole 24 hours and we may not finish. So CSG10. CSG11.
Brother Martin,
Yes, yes.
I have a question, please.
Yes, yes, proceed.
Yeah, the LSDP, is it layer 2, not layer 3? Yeah?
Anyone to respond to that? Copy it, paste.
LLDP only check the physical connection. So I think it's a layer two.
Thank you.
Yes, hello, Brother Martin.
Hello.
That, I have seen that on CSG10
Yes.
you didn't copy the command. Well, I think there's a mistake also. CSG10 same as what happened on 12.
Okay, let me just check. That's why we have the verification stage, so that we can verify everything is okay. We have the proper IP addresses configured. So you said CSG10. Yeah, see CSG10. We need to configure the IP address. And you can see clearly from here that it's telling us that you are missing some parameters. Error, incomplete command found that. So that's why I say that when you are doing the configuration, sometimes you also have to pay attention on the prompt that you are getting on the screen. So we'll just repeat it, and yeah, we finished the basic configurations. So on the next slide, now the troubleshooting commands. So once you've done the interfaces, of course, some of the few things that you need to check, for example, you need to check the interfaces on the router before you do the planning for which port will be connecting to which one. So this one, you can always use the display interface brief. When we are on the RSG one, if I run display interface brief, you can see that these are the interfaces that we have. You can see the parameters. You have the 4 gigabit Ethernet interfaces. You have 2 Ethernet interfaces. You can see the physical status. It's either up or down. If it's connected and it's through end to end, then the status will be up. If it's not connected, and definitely it will be down. So the status could be up or down on the routers. The protocol status also could be up or down. If you have configured an IP address, the protocol status will go to up. If you haven't configured any parameters, I mean any protocol parameters, the status will be down. And then you have the in utilization, you have out utilization, you have in errors, you have out errors. So these are things that you always have to pay attention to when you are doing the integration or even the daily operations. You need to log into the router, check whether you have errors on the interface, check whether the interface is up, whether it's down, whether the IP address is well configured. So you can use the command display interface brief to do that on Huawei. Another thing that you can do is display interface description. Maybe you just need to see which interfaces have which description. So display interface description, you can see that it's giving us these interfaces have these descriptions. So it's very easy to tell from the description that this interface is connecting to SG4 G002, while this one is connecting to RSG2 G002. So this is also a very important command that we need to use very often when you are managing the network. So you display interface brief, you display interface description. Another command, display IP interface brief. So now we need to check the interface parameters, the interface protocol parameters. So display IP interface brief. You can see that now we have the IP parameters. It's giving you that on gig 00 we have this IP configured and the mask is 31. On gig 001 we have this IP configured. On gig 002 we have this IP configured. On loopback 0 we have this IP configured. It's also giving you the physical and the protocol status of the IP interfaces. So if you have an IP address, it will be up both physical and protocol, especially when you have patched and the port, the physical patching is okay. So it will be physical up and protocol up. If any of them is down, definitely you won't have a connection between the two nodes. So that is display IP interface brief. It will give you the IP parameters on the interfaces. Then if you want to display the interface, maybe you just need to check like MTU, the negotiation, what, and many other details. You can also use this command display interface gigabit Ethernet 00. With this command, I will run it on RSG2. Here you can see that we get many more parameters about this interface gig 00. The interface is gig 00, the current state is up, the line protocol, we have configured IPv6 IP address, it's up. The protocol uptime, you can see that this is the protocol uptime. The description that we have provided for that interface, the maximum transmit unit, the MTU. If you've configured different MTU, you will find it here. The IP address assigned on this interface, the frames, you can see the unicast, the broadcast, both for input and output. When you have it in the live network, you can see the utilization, the current utilization. This one will always show you the current utilization of that link. So it's very easy to tell if you are having congestion on that interface, because this one will be 100%, 100%, or 90 something, which indicates that the interface is congesting. You also have the current system time. This is also very important, the last physical uptime and last physical downtime. So maybe there was a flap on the port, you can tell by using these commands. So that is the command display interface, and then you give the interface name. Another command, now we need to also check the protocol properties of an interface. So if I do the same here, you can see that we get many other details about the interface, but these were now for the IP. The protocol state is up, the interface itself physical status is up, the MTU, the input and output in number of packets. We have the received packet, forwarded packet, unknown packet, and then ICMP packet input numbers. All these details, you can see them when you use the display IP interface, this interface. So once we've done that, we will go ahead and now test the connectivity. So we have configured interfaces on this router. I'll use the display IP interface brief. You can see that we have this interface, the point-to-point interface configured. So I'll try to ping the peer node IP. So you just need to run the ping command. The node IP is 13. This should be .13. You should be able to see that. Tell me, why is it failing? We already start troubleshooting. So we can see that on gig 00, RSG2, let's check. RSG2 on gig 00, we have assigned IP 10.10.10.12. The far end should be .13. But when we ping .13, it's not going through. So we need to check on this interface. So when we display the configurations on this interface, display current configuration interface gig 0/0/0, you can see that we have our IP address configured on gig 00, which is going to SG3. SG3, which port? gig 002. So we'll check display current configuration, interface gig 0/0/2. We have the same IP address configured on peer end. So you can see this is the reason why we are not able to ping the .13. It's configured, and these are very common mistake that we do when we are doing the configurations. Maybe you are in hurry or something, you end up configuring the wrong IP on the far end device or the near end device. So you always have to do checks and confirm that you've configured the right IPs on these interfaces. IP address 10.10.10.13, mask is 31. So now we can go back to RSG2 and do another ping. Now you can see that we have reachability from RSG2 to SG3. So the problem was we had a duplicate IP configured on this interface on RSG2 and gig 002 on SG3. We can also test on this other node, display IP interface brief. So we can ping 20.20.20.11. It's okay. We can also ping .4. It's okay. We can also ping the IP on the other interface. This is 10.10.2 on gig 002. So it's okay. This one verify that our connections on SG4 are okay. We can also verify on this router, display IP interface brief. So these are just checks that you have to perform, especially when you are dealing with a live network. It's always good to do the checks, ensure that your point-to-point IPs are through. So we have .0 here, which is okay. We have .9. It's also okay. And then finally we have this one going to CSG1. So we ping 30.30.30. This one should be .1 because it's, so you have reachability on this node. So these are the basic configuration that you need to perform and the basic command that you can use to troubleshoot the IP address parameters or the interface parameters on the router. Do we have any question from the team?
Hello, sir. Can you go back to the RSG02?
Okay.
Up. You can up.
Okay.
The first ping. The first.
The first ping was here.
Yes, I think the outputs. It's receive IRP packets with duplicates IP address. You see.
Yes.
You see
So
the.
that's why I said, like, when you have this one enabled, you are very easy to tell even from the new. You don't need to start checking so many things, because you can see even the output here, it's clearly telling us that you have a duplicate IP address assigned on the interface. Thank you. On R13, display IP
Hello.
interface brief. Yes.
There's something I wanted to ask.
Yes.
On the ENSP, are you able to check the connection, let's say the fiber connection from one port to another, like the transmit or receive power level? Also, if you can check if there's any packets on that particular interface, can the ENSP allow one to do such check?
Just come again.
What I wanted to ask is,
Yes.
on the the interface
Yes.
ports, for example, G002, can you able to check the receive level or optical level or the power level on that interface?
For you to be able to do that, I think you need to have like you have the optical module, the SFP, right? And you have the fiber
Yes.
connected. But in this setup, we are just using the normal kind of the Ethernet connections, which won't allow us to check the power levels.
Okay, so in that regard, I also want to ask if you can also check packets on that interface. Can the ENSP allow that?
Which packets?
Probably if there's a traffic flowing on that port.
Yes, we can do packet captures on the ports. That one will show you when we finish the ISIS configurations. You can do
Okay,
packet
thank you.
capture on the interfaces using Wireshark, and it will tell you which packets are passing through the connection.
All right, thank you.
So I've checked also from R3 to from CSG3 to CSG14, we are not able to ping, and you can see also it's reporting the same. We have received packet with duplicate IP address from interface. So which means we also need to change the configuration on CSG14. Interface gig 0/0/0, you see it's also given 4040.2. So we'll give it an IP address of 40.40.40.3. Mask is 31. Now if we go back to CSG13, we should be able to ping that IP. So of course, these are intentional mistakes from my end, but yeah, it was just to show you that sometimes you need to troubleshoot even the basic configurations. You need to do the tests, you need to ping, you need to check the parameters on the interface just to ensure that everything is okay before you start doing further configurations. Do we have any other question before we move to the next step, where now we need to do ISIS configuration for the routers and also do the troubleshooting for ISIS? Any comment, any question before we proceed to the next stage? Okay, so we have finished the first part of our lab. The next step is to now do the ISIS configurations. So for ISIS configuration, we also need to start by doing the data preparations. And some of the things that we need to do is we need the ISIS network entity. For us to have the network entity, we need to generate it from the system IP. How do you generate the system ID from the Loopback IP? Anyone who can explain to us how to generate the system ID from the Loopback IP for ISIS network entity configurations? Guys, you are so quiet. Let's.
Yes, Martin.
Oh,
Yes.
Martin,
Yes. Proceed.
should I go?
Yes, yes, please.
Yeah, this is Aaron.
Yes.
So the loopback IP has 4 octets, right? So we
Yes.
get to, and ideally it can have. Can you go back to the loopback? Then I will go and explain when you're seeing the first one, which is like one. Am I audible?
Yes, yes, you are audible. Proceed.
Yeah. So like the first one, which is 1.1.1.1.
So you have just 1.1.1.1. Okay.
Yes. So I don't know if my method is conventional, okay, but I'll tell you how I do it. No, I'm not doubting it. I'm just saying I don't know if it's conventional or not. So I just give, I just know each octet is supposed to have like 3 digits.
Okay.
So I add the leading zeros to make 3 digits on each. So like the other one, which is 1, the first octet, which is 1, I give it 2 more zeros to make it 001, and then the other one.
We
And
go
then the
ahead
next
and do 001.001.
dot. Yeah,
Okay. Then
exactly. And then we know we need like it's in they are in four, how do you call it? I'll combine now the numbers. Like I'll combine the first four. I'll take now the first four, to put a decimal point, then get the next four and put a decimal point, and then I add that to the system ID.
So that will be the system ID.
Yeah.
Anyone with a different method?
Which is maybe conventional.
Anyone with a different method? Maybe there is a quicker way.
Martin.
Yes, yes. Let me mute. Yes, Samson. Continue.
I think the 4 octets we make them into 4 digits each.
Okay. We made.
So we make them into 4 digits each. Like we add 3 zeros. We are using 111 here, so we add 3 zeros instead of 2 zeros.
So we add 3 zeros.
Yes, on each 000.
Okay.
And then we'll remove the separators, and then now we split it into 3 octets.
So I remove the separator,
yes,
and then
we split it into 3.
3 of how many? 3 or okay, which one is the first one? First one, where do I place the dot?
I think I just got confused. Yes.
It's okay, it's okay.
I think it's a method.
Yeah, but okay, the standard method is this one. You have to add zeros, or you make them 3. So if we had, for example, 10.100.50.2, then we'll go ahead. This one, you see, we don't need to add 2 zeros. We only add 1 0. 100 is already 3. So we don't touch it. We go next and add 0 on 50. And then these 2, we need to add 2, so that 2 zeros, so that we also make it 3. So you see, it varies. It's not a standard like you need to add 2 zeros or 3 zeros. It depends with what you have. But at the end of the day, is you need to have 3. So you make this one 3, you make this one 3, you make it 3, you make it 3, and then we are going ahead and collapsing it so that we now have the 4s. So we'll go ahead and put separator here and here. And that is it. So I hope it's clear, unless there is any concern from the team. I assume there is no question. So yeah, so we have generated the system IDs from the loopback IPs using the standard convention, and these are the system ID that we'll be configuring on the different routers. We've set out the ISIS process or area that we'll be configuring. This will be ISIS 100 for the aggregation, ISIS 20 on the access. So when you have the SG1, definitely it's part of the 2 processes. It's part of the aggregation process. It's also part of the access process. So that's why we have the 2 processes here. 120, we have 130. On the access side, we are only configuring the 1 process that has been designed for. So for example, on CSG1, we are configuring process 20. On CSG11, we are configuring CSG11, we are configuring size 10. On CSG13, we are configuring, let me see where the CSG11 is. It could be a problem. This should be 30. CSG11 should be 30, not 10. And then our chain, we are configuring it in size 40. For the other parameters, we have IS level. We are using level 2. The cost style, we are setting it wide. You know, you can either have narrow or wide. Many times we choose to go with the wide, which gives you a variety, like the wide range of the cost figure that you can use. It's always good to configure the IS name. So for the IS name, we'll be using the device name. And then the network type, we'll be setting it to point-to-point. So this is the data preparation part. Now we move to the configurations. For the configurations, again, we are starting with the RSGs and then the ASGs. So for this configuration on the RSGs, you can see that we are creating ISIS process 100. We are configuring the IS level to level 2. It can be level 2, it can be level 1, 2, it can be level 1, depending on how you want your network to operate. And then IS name, we are using the device name. So we are setting the IS name to RSG01. What happens when we don't configure the IS name? We can demonstrate when we do the configurations. Then next, we are configuring the cost style to wide. It can be wide, it can be narrow. We are selecting to go with wide, especially when you have things like traffic engineering or some other requirements. You always have to go with wide. The network entity, we have the area ID. So this one will be the area ID, and then we have the system ID, and the selector is always 00 for ISIS. And then we activate ISIS protocol on the loopback. So for you to activate ISIS on the interface, you go under that interface, you run this command, ISIS enable 100, or so 100 is the process. You can see that on these other routers, you could be having ISIS 40, so you will be activating ISIS 30, ISIS 40, ISIS 20 on the respective interfaces. Once we've done that, we are also specifying the circuit type to be point-to-point. If you don't configure the circuit type, it will be broadcast. But many times on the IPRAN network, we always go with the point-to-point connection. It speeds the network convergency. You don't need to do the DIS selection and many other benefits that you have when you have the point-to-point at the network type. So we do the same for all the other interfaces. And we repeat the same for all other routers. Thing that you need to change, of course, the IS name you need to change. The network entity you need to change, and then the ISIS process that you're activating on the interface also need to change, depending on which ISIS process you've configured. Do we have any question before we go to the configurations?
Yes, Martin.
Yes.
Just one question.
Yes.
Can you briefly go to the data preparation slide?
Okay. Yeah, we are there.
Okay, that's fine. You can now go to the script.
Tell us what you are trying to confirm.
No, I'm going to ask. No, I wanted.
Okay.
I'll tell you. I'll definitely tell you.
Okay. So we are on the configuration part.
Yes. So the first thing on
Yes.
RSG, I wanted to confirm whether the RSGs were add multiple numbers, but
Yes.
I just confirmed that, so the question was not relevant. But the other question is,
yes,
for those ones with multiple IS processes, like this one, which has the ASGs, which has 20 and then 100, right?
Yes.
I've seen now 20 is for only that particular interface, and the loopback. Where do you decide the loopback to stay now? Like,
the
if
loopback
they
will
have
always be in the primary. Like if this node belongs to the
primary.
Yes.
Okay, go ahead.
You Maybe I interrupted you before you completed your
No.
question.
No.
I go ahead. Okay, the loopback will always in the primary ISIS process where the node belongs. You see, like for the CSG, they purely belong to the access process. So it will be configured in the access process. For the aggregation nodes, they primarily belong to the aggregation process. So we configure ISIS 100 on the loopback interface. So it depends which ISIS process is primary, which one is just the secondary ISIS process. But always the interface will be configured in the primary IGP process that is configured on the node.
Okay, that's clear. Then on RSG2, you're still pushing the what? The IP address command there. I thought that part we already finished. Like, is it intentional or?
This one is not required. We already finished that.
Okay.
Okay.
I've seen it. I've seen it elsewhere. That's the question. Thanks.
Any other question? As I start the configurations, we can discuss as I do the configurations, starting from RSG1. Feel free to comment and to ask your questions. So we'll do the configuration first and then move to the verification stage and show you which commands you can use to do the verification, the same way we did for the interface parameters. So this is for RSG2. This is for SG1. Any question, any comment from the team? This is SG2. Yes, Edwin, I see you are. SG3. So for SG3, it's here. We need to do the configuration. I go to the system view again and configure the ISIS parameters. Please, I'm not checking the chat, so just speak up your question or any concern. And was it Nixon or it was who? If you have any issue, just open your mic and bring it up. The next one will be to configure the CSG. So for the CSGs, I mentioned that we are only creating one IGP process. For example, CSG1, we are creating ISIS 20. We also configure the IS level, we configure the IS name, the cost style, and then configure the network entity. So similar configuration that we have done, just change of parameters. So I'll start with CSG1. So as we are doing the configuration, what do you think will cause an IGP or ISIS to fail to establish when we have configured it? What are some of the reasons that could cause the ISIS adjacency not to come up?
MTU maybe?
MTU for ISIS?
Yeah, maybe.
Anyone else?
Different hold for the hello timers.
Different hello timers.
I think if we use authentication, it must match.
Yes, if we are using authentication, it should match from the near and far end.
also, on one side, when you say ISIS circuit type point to point, then you fail to put it on the other point, on the other side, the ISIS won't come up.
True. Because by default, it's configured as a broadcast. So if you change one side, you also have to change the other side. Any other reason? Need to be in the system view before I do the configuration.
What's the default level type, Martin? Before I tell you what I think, can also
No,
say.
you can tell. I think it will be wise if if you tell us what you think first before we.
I don't know what the default type.
No, tell us what you think first,
Mm-mm.
or
What
anyone
I
who can
think.
Martin,
respond to CSG5.
the, the, the ISIS process,
Yes, Samson.
the ISIS process should be the same on each end.
The SIS process. So if I configure SIS 10 one side and SIS 20 on the other side, it will not come up.
Hello, Martin. I think also LDP configuration, if LDP configuration is mismatch, the
LDP.
ISIS, yes.
How does that one come in? SIS and LDP, CSG7.
Like if you configure LDP on the interface,
Then you enable SIS, it will not come up.
no, for example, if LDP is configured on two interface and also ISIS,
Yes.
but the LGP configuration is not don't match. If we configure LGP on one interface and don't configure in the second interface.
LLDP or LDP?
LDP,
LDP, the label distribution protocol.
yes.
That one will not prevent SIS from coming up because you see SIS and LDP, they are two different protocols, but of course they work together. You need to configure synchronization between LDP and IGP, but they are two separate protocols, so that one should not affect the adjacency from coming up.
Okay.
There was a question on which SIS level is by default. Which one is the default SIS level?
I've got it, Martin. It's 1, 2.
Okay. What was the initial? Because you said you had a separate thought.
No, I was just thinking if I put 1, 2 on the other side and 2 on this other side.
Yeah, if you put 1, 2 on one
the
side and 2 on the other side, definitely it will establish level 2 adjacency.
Yes. So
Yes.
that's what I was thinking. I wanted to first confirm the default level type.
Okay. But if you put level 2 and level 1, it will not come up.
Yeah.
Yeah. You can put level 1, 2, and 1, it will come up. Level 1 and 1, it will come up.
1.
Level 2 and level 2, it will definitely come up. But level 2 and level 1, it will not come up. CSG11, CSG12. Any other reasons why it could fail to come up? Guys, we have done this and we have troubleshooted these things for long hours just to realize that you forgot something small in the configuration. CSG12 and then CSG13, which we are configuring as IS process 40. Or you've never had an adjacency failing to come up. CSG.
Already.
Yeah, I feel if you have done the configuration at some point, definitely. At some point you had to troubleshoot and to. So we have finished the IGP configurations on all nodes. So the next step will to go ahead and check the command that we can use to troubleshoot these adjacencies. So once you've done the configuration, the next stage you will now to verify whether your adjacency are coming up, why they are not coming up, and whether you have any issues that could be causing them to fail to come up. So we have been activating ISIS on the interfaces. The first command that I will use, I'll check the ISIS peer. So you run the command display ISIS peer. It will show you that these are the peers that you have on the node. These are the adjacencies that are up. So I'll go to RSG1. On RSG1, you can see we have how many connections. We have 3 connections. So we expect to have 3 adjacencies for ISIS 100. So on RSG1 display ISIS peer, you can see that we have 3 adjacencies. We have adjacency to SG4, adjacency to SG1, and adjacency to RSG02. So you can see this is where the IS name that we configured is coming in. It's clearly telling you, instead of using the system ID, it's clearly telling you that this is the peer to SG01, this is the peer to SG04, this is the peer to RSG02. If we go ahead and do a configuration change, for example, I change the IS name. This is IS 100. If you display these, we can see the configurations here. If I change, maybe undo IS name, it will pick the system ID, and it may be very hard for you to tell which peering sessions you have on the router. So when I come back to RSG1 and now display ISIS peer, you can see now what we are getting. How can you tell that this system ID belongs to SG4? Unless you have really mastered the system IDs for all the nodes. So you can see how this one comes in use. We are now getting the system ID instead of sysname. So for me to be able to get the sysname, I need to go back and configure the IS name to SG04.
Sorry, Brother Martin.
Yes.
Sorry. Please, the system ID and the process ID is the same thing, right?
The system what and the what?
System ID and the process ID is the same thing, right?
No. The system ID is coming from the network entity that we configured on the node. The process ID, we configured process ID 100. The system ID, we also configured the network entity. So if I display current configuration ISIS, you can see that we have, this is the process ID 100, and then we have configured the network entity. So the system ID is
Okay.
picked from here.
Okay. Okay. Thank you.
So you've display ISIS peer, you can see that we have ISIS peering sessions, display ISIS peer again. You always have to, you can see the peering session. You can use the verbose command to get more details of the ISIS peering session that you have. You can see SG4, you have the parameters, the area address, the peer IP address, the session uptime, the adjacent protocol, restart capable, yes or no, suppressed adjacency, such like parameters. When you're troubleshooting, definitely you need to check more details about the protocol. So you use display ISIS peer verbose, and then you are able to see much more details about the ISIS adjacency on this router. When we go to RSG2,
Martin,
yes,
what is that circuit ID parameter? We didn't configure it.
which one?
This on the command output for the display ISIS peer, the system, the headings. Yeah. So you see system ID in the first circuit ID.
Yeah, we haven't configured the circuit ID, so this one is now generated just randomly. because we haven't configured any circuit ID, right? Maybe we can explore more how it's generated, but for now we can just take it as it's generated randomly. You can see every adjacency has picked a different circuit ID. Yeah. So we can check on RSG2. We display ISIS peer. We get that we have 4 adjacencies. We have adjacency to SG4. We have adjacency to SG2. We have adjacency to RSG2. You can use the verbose command also. Let me clear this. Display ISIS peer verbose. So you get the same output. We go to SG1. So SG1 display ISIS peer. You expect to have 2 adjacencies, 3.
Martin.
Yes, yes.
Okay. Show ISIS peer and show ISIS verbose. So maybe I pronounce it wrongly. Is there you will get a different output?
You looking at my screen or you have a separate?
No, I am looking at your screen now.
Yes, this is the output for display ISIS peer. You can see that it doesn't give us much more details about the adjacency. But when we do the verbose one, it gives us much more details about the peering session between the 2 routers.
Okay. So the best one is to use verbose, right?
It depends. It depends what you are looking at.
Okay.
Yeah.
Thank you.
So we were on SG1. On SG1, you expect to, when we run display ISIS peer command, you can see that we have one adjacency in IS100, and then we have another adjacency in ISIS20. You realize that we are missing an adjacency between SG1 and SG02. Right, we expect an adjacency, 2 in S100, I mean in ISIS100, and 1 in IS20. So we need to check why that is the case.
Let's start with the point to point if it's going
Although we already checked point to point display IP interface brief. Yeah, we'll go with your suggestion. So which interface is connecting to SG2? This is 001. So I will ping the point to point 10.10.10.9. It's true. What next? We've checked the point to point is true. What should we check next? For those one who had suggestions of what could cause the adjacency to fail to come
We
up.
check if ISIS is enabled on the interface connecting to that.
Okay.
I think display ISIS interface.
ISIS interface. We have in IS100, we have ISIS enabled on these 2 interfaces. That is okay. We go to SG2, right? We do the same. ISIS100 interface. You have ISIS enabled on the interfaces. What next? Guys, bring up those reasons.
Let's display the current command, display the command on the interfaces.
Display current configuration interface gig 0/0/1. These are the configurations on the interface.
100 P2P. Check the remote side. Check on RSD2.
Okay, it's the same interface. Display current configuration interface gig 0/0/1.
P2P. Put it as P2P.
Yeah. So yeah, those are part of the troubleshooting that have been set up for the lab. So yes, we found the reason. It's because we have not configured the point-to-point network type. If I display ISIS error, should I get any outputs in ISIS 100? This is not there. Let me check on ISIS error. You can see here clearly that it's telling us that we have bad circuit type configured. So you can use the command display ISIS error, and clearly it's telling us that we have bad circuit type configured. So we are right there. Let me clear this, and it's only indicating on the far end device. So I need to configure what was that command, circuit type point to point. Now we expect our ISIS to come up on SG1. Display ISIS peer. Now we have our adjacency that is up. Thank you, Aaron. You got it right. But you can see that we have done some step-by-step checks for us to be able to identify that this is the reason why our adjacency is failing to come up. We go to SG04. SG04, I also expect to have for 3 adjacencies. I display ISIS peer. I only have one ISIS adjacency. Why?
Display ISIS error.
No. Sometimes, sometimes that's not the case. Tell me something else. We are not going straight to the ISIS error. You see, we'll be using the ISIS error, but now in a real maybe exam or what they are asking you the reasons, not you don't have the machine to go and check maybe. So what should we check first? You can see we only have an adjacency to RSG1. So this one is okay. From here to here we have adjacency. We don't have adjacency between SG04 and CSG07, SG04 and SG03. How do we proceed? Yes, James.
Display ISIS interface.
Display ISIS interface. We have gig 001 and gig 002 in ISIS 100. We have gig 00 in IS30. Is that okay? Yes, right, because we expect to have these two interfaces in ISIS 100, this interface in IS30. So that is okay. Next. Next.
Check the
You can
pin.
check the configuration on each interface.
We check the configuration on interface facing SG03. Okay, let's check that. So display current configuration, interface gig 0/0/3. We don't know. This one should be 2 or 3. This is at 1. 001. These are the configuration. We have ISIS configured. We have circuit type set point to point. What else can we check on SG04? James, you
Confirm on the peer side also.
so we are following the same roadmap. So it's gig 001, display current configuration, interface gig 0/0/1. We have ISIS enabled, we have ISIS circuit. With
Check
the link.
ISIS configuration.
.4.5.
Yes.
So the point to point is okay.
Check ISIS configuration both sides.
Configuration ISIS. These are the configs. We have ISIS 30, we have ISIS 40, we have ISIS 100.
On the peer side.
On the peer side, this is SG4. Display current configuration, configuration ISIS. Okay, we have ISIS 30, we have ISIS 100.
You can check the network entity if we have same network entity on the two sides.
Network
Compare.
entity.
Yes,
This
compare.
is,
I think the network entity is the same.
so now we can check our ISIS error. So on ISIS 100, repeated system ID. So it's clearly telling us that we have repeated system ID configured. So let's check, just go back to our configurations. So on SG4, the IP address is set to .5. So this one needs to be set to .5. Then we'll remove ISIS 100 and then just reconfigure it. Undo ISIS 100. Yes. Then we'll reconfigure ISIS 100. Go back to, so SG4 display ISIS peer. We now don't have any peer at all. We need to enable it on the interface also. So let me just copy the interface configurations again and do the configuration on SG4. Display ISIS peer. So we now have two adjacencies on. We have adjacency to RSG3 and RSG1 and SG03. So we are okay in ISIS 100. We expect a peering session towards CSG7, which is in ISIS 30. So we also need to perform checks on the same. So on SG4, display current configuration, ISIS 30, display current configuration, configuration ISIS. We have ISIS 30 configured. The network entity is well configured. Display ISIS 30 interface. We have gig 00 in ISIS 30. Let's check on CSG7. Again, display ISIS interface. We don't have any ISIS interface. Display current configuration, configuration ISIS. Maybe we forgot to configure it. We have ISIS 30 is not configured on the interface. So we check on this gig 001, we should be having, which is CSG7. Let me go to my configuration again. So the problem is we configured the wrong ISIS process. That's why it didn't pick, because for you to activate ISIS on an interface, that ISIS process should be existing. So we also need to change to loopback 0. So these are just some of the things that are intentionally left out so that we are able to see how you can troubleshoot these adjacencies when you are doing your deployment in the live network. So I will now check again, display ISIS peer. you have an adjacency on SG4. This one, display ISIS peer, you now have an adjacency in ISIS 30. That looks okay. The last, we check on CSG4. On CSG4, where is CSG4? This is CSG4 display ISIS peer. You realize that on CSG4 we also don't have an adjacency. Display ISIS interface. You have ISIS enabled on the two interfaces. Display current configuration, configuration ISIS. You have it configured there. You have it enabled on the interface. If I display ISIS error, repeated IPv4 address or unusable IPv4 address, this one new or all, not sure, but we can recheck. We check on SG2, display, let me admit someone, display ISIS peer, you have only in aggregation. If we check display current configuration, configuration ISIS, this is ISIS 20, this is display ISIS 20 interface. We have it in gig 002. If we check the current configuration on this interface, circuit type is well configured, ISIS 20, the point-to-point IP is configured. We check on CSG4 the same, which interface, this one should be gig 001. Current configuration, interface, gig. So you see we have a duplicate IP configured because we did not perform checks to check the connectivity between the two nodes, so we ended up having the same IP configured on the point-to-point link between these two devices. That's why when you are doing the configuration, it's always to do the checks before you move to the next stage. So this one I'll give it 3032, and this one should be 3. Then mask is 31. Display ISIS peer, still not coming up, being 30.30.30.2. Still no adjacency. What else can we check? Circuit type is set to point, which is okay. On SG2, the circuit type is set to point. The point-to-point is reachable. This is gig 001. What else can we check to ensure that our adjacency is up? Guys, you are too quiet.
Can you
help me to troubleshoot?
what
So
in
that
your noise?
we move to the next step.
Can you display the config for ISIS?
Display current configuration, configuration ISIS. Yes.
Level 1.
Thank you. So it's ISIS 20. We set IS level 2, because the other side is also level 2. Yeah, and our adjacency should be up. We only have SG2. We still have the one to SG1 not up. We can also verify. Display current configuration, interface, gig 0/0/0. You have ISIS enable, point-to-point, circuit type is set to point-to-point. Let's check on this one. Display current configuration, configuration ISIS, and then display ISIS peer. You only have one to CSG2, so you need to check, like, let's see, we have ISIS enable, display ISIS interface, you have ISIS enabled on two interfaces, 00 and 01, which is the other interface, 00 and 01. We need to enable it on 02 also. Interface gig 0/0/2, ISIS enable 20, ISIS circuit type, set to point, display ISIS peer. So we now have to adjacent these, which means on CSG, this one we haven't configured the IS name. Display current configuration, ISIS. IS is set to CSG05, which is okay. We have adjacent the ISIS peer. We have the peer. So the only pending peer is between these two nodes, display ISIS peer. We still have no adjacency between the two nodes. Let's do the basic checks, starting by display IP
Hello,
interface bridge.
hello,
Yes,
Professor.
yes.
Yes, display. Can you run display ISIS interface
Display ISIS interface.
on CSG03?
CSG03, okay. Let me clear this. Display ISIS interface.
Yes,
There's something about MTU there, Martin.
port gigabit 0/0/0
Can you
0.
show run interface
Is I
000?
think is this port is down
Display
or
current, display
something
interface
wrong.
000.
0/0/0. Line protocol
What's the
current state is down.
Line is down. Yes.
Meaning?
No IP address or
We have an IP address assigned. This one was which interface? 00. So interface gig 0/0/0. Display this. We don't have an IP address
yeah, we don't
configured.
have IP address.
So we give IP address 30.30.30.11. Let me just confirm on CSG4. This is 11, so this one should be 10. Mask is 31. Display ISIS peer. Yeah, and now you have your adjacencies. So those are just some of the reasons that will cause an adjacency to fail to come up, and you need to troubleshoot, check step by step, see why they are not coming up. Yeah, but we move to the next. I know we are remaining with some few minutes, but we still need to complete this session. So these are the commands. You display ISIS IP routing table. You will see the ISIS routes. You display ISIS LSDP. You display ISIS name table. You display ISIS SPF log. This one has been very handy, the ISIS error. And we can also do a packet capture on these links to see the ISIS packets that are flowing on the interface. So when I run start the capture, we should be able to see the ISIS packets that are flowing between the two interfaces. All these are ISIS packets. You can see the ISIS hello, you can see the parameters, the circuit type, level 2, the area address 490100, and many other parameters that you can be able to see. The logical link, control, the ISIS intra-domain routing information exchange. You can see all these details when you do packet capture on these interfaces. Hope we are clear. So these are the commands. Any question before we move to the third step? Okay. Any question? Any question on the ISIS troubleshooting and configuration?
Hello, Martin.
Yes.
I have a comment. Okay, more like a suggestion.
Yes.
I'm not quite sure whether you've, in your previous sessions, you've touched on ISIS protection,
Protection, like how do we
like
protect it?
using L2VCs.
No, we haven't done that. This is the first class on the IGP lab, but definitely we can have, you see that one requires a scenario that we really need to do the configurations of that. So we can have a session on that in the coming episodes where we touch on the protections like the network, improving network, availability or something like that. Because all those protection they come in when you want to ensure that your network is able to switch, you don't have the downtime and all the other. Right. So we can have a session on that and we'll go deeper into it. So to the third part, we only have two parts remaining. Hopefully, they are just few configurations. But at this stage, we have now configured ISIS in these different rings: ring 1, the aggregation ring 1 also, and access ring 2. We have also had an extension of a chain here. So now we need to go ahead and ensure that we have communication. As things stand now, this router will not have the loopback IP of this router. Even CSG1 that is directly connected to SG01 will not have the loopback IP from SG1. Why? Because we haven't done any route import between the two aggregation, the aggregation and the access process. And remember, at the end of the day, you will have to configure BGP using the loopback IP from CSG1 to SG1. So that's why we need to perform some route import between the access and aggregation processes. So we'll have to import some route from ISIS 20 to ISIS 100 and also do the same from ISIS 100 to ISIS 20. Here we do the same. We need to import some routes from ISIS 40 to ISIS 100 and we also need to import some route from ISIS 100 to 40. This is just to ensure that we have end-to-end connectivity in the network. So, before you do the route import, the first thing that you need to do is to determine which routes you want to be exchanged between the access and aggregation. You need to configure IP prefixes based on what the routes you want to be imported. So you configure prefixes, you configure route policies, and then you perform the import between the access and aggregation. So I mentioned that when we go back to the topology and on CSG6 display ISIS peer, we have the ISIS peer app display IP routing table. You can see that we have all these routes have been learned from ISIS, but we don't have the loopback IP from SG01. So if I display IP routing table 1.1.1. This one was which one? The system ID, it's .2 from this router. .2, you see that we don't have the route because they are in two separate processes. So we need to perform the import for us to be able to have reachability between the nodes. So for the configurations, very easily, we need to first know which routes we need to import. So I will just demonstrate using SG01 and maybe SG02 because we need to do another step of closing the ring. So we need to configure the IP prefix. This is how you configure the prefixes. IP prefix, you give it a meaningful name and then index 10 permit that number. And then we are also configuring another import access to aggregation prefix. And then we give the greater than or equal to 30. So we are importing the point-to-point between the routers. So I'll go ahead and configure these on SG1. So on SG1, please mute. So I've configured the IP prefix. I need to go ahead and configure now the route policy. So the first route policy we have two route policy. The first route policy is to Abdi, you can mute, please. The first route policy is to import access to aggregation. You can see that we are using the import access to aggregation, this one, and we are importing the point-to-point and the loopback IPs. The second route policy is just importing the loopback IPs from the aggregation to the access. So I'll go ahead and configure this route policy. Still on SG1. I'll paste it. And then finally, we now need to perform the route import between the processes. So from here, you can see that in ISIS 100, we are importing ISIS routes, ISIS process 20 routes, and we are using this route policy. So we won't be importing everything. In ISIS 20, we are importing the direct routes, and we are only importing the loopback IP of the SG. The CSG doesn't need to know the point-to-point IP configured in the aggregation. No need. Sometimes maybe they don't even have the capacity to handle those many routes. So on SG1, we'll do the same. And now, if I go back to CSG6 and I display the IP, I expect that it should now come in once the policy is applied. Let's just verify again our configurations. Display current configuration. Configuration ISIS. So we have import route direct, route policy, SG1, I see the problem. You can tell us the problem. The route is not coming because of the prefix we have configured. So we need to edit this prefix to the right prefix. Remember the loopback IP from this node, it's 1.1.1.2. So we'll just change the prefix to 1.1.1.2, and that is it. So on SG1, and now when we check on the CSG, we expect to be having the route. Now you can see that we are able to get the route from the aggregation process to the access process. This one, given that it already has two processes running, definitely it will have these prefixes in S200, I mean in S20. But for them to be able to be reachable in S100, you also need to do the import. So on this router, if I now display IP routing table, you can see that we are able to get all these routes. All these prefixes are now coming in after we have done the route import between the access and aggregation processes. I'll just do similar configuration on SG2 so that it will help us to perform the next step of configuration. So it's 1.1. Let me check the loopback IP of this router, 1.1.3. I'll delete this so that I configure it once. Control copy, go to SG4, SG2. And then paste. So we now also expect to get the loopback IP from this router in our aggregation process.
Hi, Martin.
Hi.
Someone's hand is up, yeah? Baltazar.
Yes, you can just proceed. Hello, ask your question, please.
I don't have any question here. There is some mistake, but I didn't raise the hand.
Okay, no problem.
Okay.
So this is just to demonstrate that yes, you need to perform the route import between the access and aggregation to ensure that any device or any user who is connected to this node should be able to reach the other external IP that are coming in from the aggregation process. I hope that's clear, unless there is any question that we need to clarify.
Yes, Martin, just briefly on the imports, I'm seeing
Yes.
you're importing from the aggregation, you're importing to the access ring, the loopbacks majorly only, right?
Yes, yes.
And then from the loopbacks to the aggregation, you're taking the point to point also? From the access to the aggregation.
From the access to the aggregation, we are we are taking both the system IP and the, because you can see we are specifying that index 10 permit 0.0.0.0/30, and it's extending to greater equal to 30 and 32. So we are taking like /30 IPs, right? /31 and /32. So /32 will be for the loopback IPs, /31 is for the point-to-point IPs. Right.
Okay, why is it important for the point to be in the aggregation?
Especially when you need to, you see, the aggregation should have all the routes. The aggregation should have all the routes, so that even when you, for example, if I want to check which point-to-point IP is used in this network, I will still check it from the RSG, because at the end of the day, all that information should be available in the aggregation.
Okay.
But for the access, no need.
And there is also no need for the access to have loopbacks. For like access ring 1, a route like which one? For CSG3 in access ring 1 does not need to have the loopback for CSG8 in ring 2, correct?
Yes, no need, because if it have to communicate, they will only communicate on the service level, but not on the normal IGP level. No need.
Okay. Thank you.
So the next step is to perform the closing of rings. So for the closing of ring, the concept is very simple. I think we discussed it. So you have your setup here. This ring is now running all the way from here to this node. So you have kind of a black hole here between the two nodes. Why? Because when you are doing the BGP configuration, imagine you've lost this link. Yes, your BGP can still be established to this node, but still we can have the BGP established to this node if we if we close this ring that is in between the aggregation nodes. So what we need to do is we'll extend that access ISIS process from this node, we extend it to this node. So we'll have a fully operational ring, IGP access ring operating between the nodes. So these aggregation nodes will be fully part of the access ring, and the access ring are now terminating on the both SGs without any issue. So even if we lose this hop, we can still get routes from this guy from the other side. They'll come through because we have the ISIS-20 configured between the two nodes. How we do it? Because here you've already configured ISIS-100. So how we do it is we create sub-interfaces, and then on the sub-interfaces, we activate ISIS process 20. We give it a higher cost because we don't want it to be used at any time unless it's the only available path. So it's very simple. We create these configurations. Interface gig 001. We are giving it the VLAN.eq because this is a sub-interface, so we need some kind of encapsulation. You give it a description, and then you assign IP address, you enable ISIS. Of course, you can configure the circuit type and all the other parameters. And then you just verify that your adjacency is up. So this is for SG01. So on SG01, let's just verify the interface again. I'll configure this. And then on SG02, we'll do the same.
Martin, can you come again on why you're not putting it on the physical interface itself and you're creating a sub interface?
The physical interface already has existing as IGP configurations. Right.
In the main ring.
Yes, yes. We have already activated ISIS 20, ISIS 100 between SG01 and SG02. And another way is we can have both IGP processes on sub-interfaces. We can have gig 001.100 for ISIS 100. We can have gig 001.20 for ISIS 20.
Okay.
But the moment you have multiple processes, unless it's you still have you have to go and create sub-interfaces for the separate connections. So now with this, you can see that our ISIS display ISIS peer. You have another ISIS in process 20, and this is on the sub interface. So that is okay. It confirms our configurations are okay. Our adjacency is up. Any question before we move to part 5? We are almost done. So in part 5 is just on cost configuration. So for cost configuration, we discuss different modes: the interface cost, global cost, or the automatically calculated cost. Many times on IPRAN network, we go with either the interface cost or the automatically calculated cost. And this is how we demonstrated how you configure interface, and then you configure the cost manually, or you configure the bandwidth difference for the automatic calculation of costs. You can also have the circuit cost configured, but many times we use these two. These are the configuration, very simple. Interface gig 001, that is the command. ISIS cost 50, ISIS cost 100. The cost will always be determined based on your standard design. Many times on the access ring we configure maybe 100. In your side it could be 1,000, it could be any that you've designed or any that has been approved by the network design team. That's the one that we'll be using. And then between aggregation nodes, we configure cost of 50. That's why on this interface you see cost of 50. This one you see gig 001. You see the different interfaces configured with different costs. So this is a very straightforward step. We won't go into details. The next part is
Yes, Martin.
Yes.
It's straightforward, but what are some design principles when you're considering cost calculation, cost computation to apply? Like, I know the cost will influence path selection, is it?
Yes.
Like which? So, what are the design principles when you're considering that? Because looks like all for our case, right?
Yes.
All of them. Ideally, I would think maybe bandwidth or something. There's no stability of one path or the other, but for our case, like everything is equal.
Yes, it's equal.
Those numbers you've put, is it based on?
No. Of course, you've brought in the idea of the link capacities. That one definitely. For example, you can have a microwave protection, low capacity link. Definitely, that one you end up giving it a very high cost. So of course, the capacity will always be considered when you are doing the cost design. And sometimes also the vendors will tell you the standard design, like for this access to aggregation, configure this value, this value, this value. But at the end of the day, it purely depends on how you want the traffic flow, right? If you want the traffic to go via this path and not via the other path, then you increase cost on the other path, or you configure it to be high. Is that okay?
Yeah, it's fine. It's okay.
Okay, so next step is to now check on the authentication. So for authentication, definitely we need to consider the network security. So that's where we are bringing in the authentication. And for you to do the authentication, many times we use MD5 authentication. And when you configure MD5 authentication, many times you need to ensure that you configure it on both ends of the router. You cannot just configure it on one end. For example, if I just take these configurations on RSG1 and go apply on RSG1, so we have configured authentication on all these interfaces. If I display ISIS peer and give it time to time out, so it will take some time to time out. Display ISIS error, maybe also this one can tell you like you configured some parameter that are not matching, but let's just give it time to, you can see the peer down hold time expired because do we have anything to do? Yeah, you can see here mismatched protocol, mismatched authentication. Trying to see the details, but if I run display ISIS peer, you realize that now we don't have any adjacency between the two nodes, the 2 or 3 nodes that are configured with authentication. Because when you do the authentication configuration, you always have to configure the same parameters on both ends of the link. So we need to do authentication on RSG02. So I'll go ahead and do similar configurations here. Paste, display ISIS peer. It will take time to time out ISIS peer. Now we have an adjacency to RSG2. So it was down, now it's up because we've also configured authentication on the other end and it's now matching. So when you configure authentication, always ensure you configure the same parameters on both sides of the link and ensure that it's configured end to end. Don't just configure authentication in one section of the network and leave the other. No, do it end to end. The final part of our lab is on improving network convergence speed. So for network convergence speed, there are some parameters that we mentioned last time, some mechanisms. For example, you can set timers for the SPF calculation. You can enable ISIS intelligent timers. You can implement BFD, the bidirectional forwarding detection for ISIS. So these are just some of the parameters that can help you to speed up the network convergence. Whenever you have an issue, whenever you have a fault, maybe link fault or node failure, the adjacency will come up faster, or it will reduce the amount of resources utilized on the device. For example, if the SPF algorithm is always running on your router, you see it ends up consuming some resources on your node. So set timers for SPF calculation, enable ISIS intelligent timer, implement BFD for ISIS. Those are just some of the things that you need to do to ensure that you have faster convergence of your network. How to do it? You need to do the configuration under the ISIS process. For example, you can see that we have adjusted the timer LSP generation. So this is setting the time of LSP generation. The initial, the increment is set, and then we are also setting it to level 2. So this one only impacts level 2 connections. We are enabling BFD all interface enable. So this one, what it does is any interface that is running ISIS will have BFD enabled also, because we are enabling BFD on all interface. And then we are also setting the min TX and the min RX for BFD protocol. We are setting the timer for SPF calculation. We are also enabling traffic engineering level 2. So this one of course comes in when you have the PLS traffic engineering enabled. So you also need to configure the traffic engineering when you have PLS TE enabled in your network. So you do the same on all the other routers. Set the timer LSP generation, enable BFD, and then set the timer for SPF calculation. You can implement other mechanisms like the loop-free alternate. All those can be implemented to ensure that you have faster convergence of your network. Do we have any question?
Hello, sir. What the timer SPF is used for?
This one is meant to, you see, there ISIS determines like the best route. It has to do the SPF algorithm. It has to run the SPF algorithm. But again, you don't want it to keep running all the time. There is an issue or something. It has to run the SPF algorithm. No. So you set the timer so that at least maybe you may delay, especially for a network that is not stable, you delay the SPF calculation algorithm from running very often, or if the network is too unstable, then it means the algorithm has to run more often to ensure that you have the routes. So it purely depends on your network, how stable is your network. So you set the SPF. SPF is the algorithm that we use to determine the best path in ISIS. Like you, before you install the routes, it has to run the SPF algorithm, and then it will be able to now find the optimal routes to be used. So you are just setting the timers or the frequency of SPF algorithm running on the router.
Okay, thanks.
Someone is raising their hands. Any question? Any question? I think we are already to the Q&A. Any question? Any comment? Before we close our session, we've extended it past the 4 p.m. Guys, unmute your mics and ask questions, comments.
I don't have any questions.
Okay. Anyone with
I
questions?
think it was a nice session.
Yeah, I will share the PPT. I will share the PPT has the configuration, so you are also expected. You can do the labs. You can do the simulations in your own lab. You could be using more of Cisco. You can do similar implementation on Cisco. You can do similar implementation on Nokia or your favorite vendor that you have in your lab setup.
Martin, can you kindly share the ENSP image, please?
You require the ENSP image.
Yes, I don't have.
Yeah, it's okay. I can share. I can share it when I'm sharing the files, or you can,
Yeah.
because it's a big file, so you can also ping me directly. Then I
Yeah,
can
I'll
share
ping
with
you.
you. It's
I
a
just
big
figure
file
out
to share.
probably maybe some other member also require, and then you do. But anyway, I'll ping you.
Yeah.
All right.
Any other question that we are leaving out before we close our session? Okay, guys, then thank you for joining this session. This was our third session, and I've said that we'll be having multiple sessions after every 2 weeks, just to speed up and close on this IPRAN training. So I hope you've enjoyed the session. If you still have any question, feel free to reach out to me. I'll be sharing the recording after some time, probably tomorrow. Tomorrow during the day, you can access the recording and yeah, have a look at it. We also have other videos recorded for the previous sessions. You can also check them out just to help you understand this IPRAN thing clearly. So thank you, and see you in our next session.
Thank you.
All right, thank you very much. It's really nice,
Thank you. Thank
and
you.
I guess I'm following up a bit. That's nice.
Thank you
Thank
for
you. Thank
joining.
you.
Thank you.